Hello everyone, so this is a video on P5, which is a great review of factoring polynomials, okay? So after this video, hopefully we're going to be better at factoring in 4 different ways. So we're going to practice factoring regular quadratic expressions. We're going to practice factoring by taking out a common term. We're going to practice factoring by grouping, and also by using the difference of squares identity, okay? So hopefully I'm going to get all 4 of these in this video. If not, I'm going to make a second video. But if you're good with one of these, feel free to just take some notes and just go listen to the part where you need to review, okay? Maybe you're good with difference of squares and just need to focus on the other 3, but this really is another review because you've learned it in previous years. So let's start by basic factoring, okay? How am I going to factor x squared plus 7x plus 10? Now, if you know how to do this and you have a method that works for you, awesome. I encourage you to use that method. I might be showing you a different method or a different way to think about it or write it, which also would be a good purpose for you to watch it and listen to the video. So here we go. When we have to first of all remember standard form of a quadratic expression has ax squared plus bx plus c. So we need to remember, like, there's an a here, which is 1, my b is 7, and my c is 10. Okay, those are the coefficients, and I review that because we have to come up with factors of the c, I'm going to say, and that add to b. Factoring brings us to this factor setup of binomials, okay? When x equals 1, my binomials, when I factor this, will have x's in both of the first terms in each of those binomials, okay? Because when I FOIL that out, I'm going to get that x squared in my original. And in order to get my other terms in each of these binomials, I make a chart to organize my third step here. I write, okay, so I'm going to need factors of c, my c in this case is 10, that add, the sum is 7. Okay, I make this chart. And then I just come up with them. Okay, so what are factors of 10? 1 times 10, right? 1 times 10 gives me 10. But when I add 1 plus 10, I get 11, which is not what I want, right? There's my sad face. I want 7. So let me keep thinking. Okay, factors of 10, 2, and 5. And when I add 2 plus 5, I get 7. Perfect. That means 2 and 5, those are both positive numbers, are my values in my factoring form up here. Okay, and there's my answer. X plus 2 times x plus 5. So like I said, I make this chart. You'll see me do it when I factor. If that's going to help you, try it out. If not, you have a method that works, stick to that. Okay, let's try factoring by taking out a common term. Okay, very similar. Make sure we see and recognize that this is standard form. You can see my a, my b, and my c. Here, when I realize my a isn't 1, right, my a is 2. Up here, my a was 1. There wasn't anything, which I know is a 1. Here, my a is a 2. When that happens, when a does not equal 1, I need to determine if there is a greatest common factor in my numbers, my coefficients a, b, and c. So I see my coefficients are 2, 4, and negative 30. Is there a number that I can divide all of those numbers, 2, 4, and negative 30, by evenly? And I can, right? I can divide each of those numbers by 2. And that's what we mean by taking out a common term, okay, a common factor. I realize that 2 is the number that I could divide each of those terms by. So I take that 2 out, and then what am I left with after I divide each of these terms by 2? And if that helps you to write divide by 2, divide by 2, divide by 2, do it. So 2x squared divided by 2 is going to be left with an x squared. 4x divided by 2, I'll be left with 2x. And negative 30 divided by 2, I'll be left with negative 15. Wonderful. Okay? Notice now, what's in the parentheses, I'm back to my x's, my a is 1, and I can factor using these steps. Okay? If you want to check to make sure you took out that common term out correctly, you just distribute it back, right? Multiply that 2 back in, and you're going to get our original, okay? So I need to factor what's left in the parentheses. I make that chart. I need factors of negative 15 that add to 2. Factors of my C value that add to my B value. Okay, so numbers that multiply to negative 15, I think about negative 5 and 3. Negative 5 times 3 gives me negative 15, cool. When I add negative 5 and 3, I get negative 2. Bummer, which is not what I want. So let me keep thinking. What if I multiply positive 5 and negative 3? Cool, I'm going to get negative 15. And now when I add 5 plus negative 3, I'll get my positive 2, which is what I wanted. So now, guys, when I go ahead and write my factor setup with those x's in both of the binomials, what numbers come after those x's are right here, those numbers that worked in my chart, that made my chart true. The positive 5, right, because we wrote a positive 5, and my negative 3. And that's how I factor using that chart. That 2 has to be out front. Notice that 2 is out front because I took it out in the very beginning, so it has to stay there. Cool? Wonderful. We're flying through. Let me know if you have any questions in the chat or shoot me an email. Okay, third method, factor by grouping. So we are only factoring by grouping. I know I have to do this process when I realize I have 4 terms. So count those terms in that polynomial. I have 4 of them. That means I have to do this process to factor. Okay? And what I do, the very first thing, is we have to group them, right? If I had 4 students, I would group them in groups of 2, right? 2 students over there, 2 students over there. Same thing. I have 4 terms, so I'm going to group them in groups of 2. And when I group, mathematically, we're going to use parentheses. So I group the first 2 terms together, and then I keep that plus sign in the middle, and I group the last 2 terms together. Literally, I didn't do anything but parentheses around the first 2 terms and the last 2 terms. Okay? And now we're taking that same step that we just did before of taking out a common term. Okay? Just like we did here, we're going to do that with these mini groups. So we just need to focus on the one group at a time. So x cubed plus 5x squared, what do both of those terms have in common? Well, I notice they both have x's, right? And how many x's could I take out of each? The first one has x cubed, 3 x's, and the second one has x squared, 2 of them. So I could take at most 2 from both of those terms. And when I take an x squared out of x cubed, I'll be left with just x. And when I take an x squared out of 5x squared, I'll be left with 5. Okay? Again, if you need to write like the divide by x squared under both of these, you can, but just it's a visual. Same thing now we have to do with the other group. What can I take out of 4x and a 20? What do both of those terms have in common? So I think about 4 and 20 on the side. I could divide both of those numbers by 2, but also something greater, 4. So when I take a 4 out of 4x, I'll be left with an x. And when I take a 4 out of 20, it's division. When we say take out, we're doing division. I'm left with 5. Okay, so that's that third step. Now, when you're always done that third step, you must have the same group, the same parenthesis left over. If you don't, you did something wrong, so go back. I have the same parenthesis left over. And now, guys, go back and there's like a pattern here. Every time we factor, I'm always left with 2 sets of binomials, right? Maybe a number out front. 2 sets of binomials, okay? So I need to get those 2 binomials here. How I get that factor setup, that's what I call it. How I get those 2 sets of binomials is I need to look at this group as a whole and this group as a whole, okay? What do both of those red chunks have in common? The common term between those 2 red chunks is the x plus 5, right? So I take that x plus 5 out of both of those terms. I pull it out of this term, okay, and I pull it out of this term. When we take out, notice it gets written on the front, and what's left over is going to be those terms in front of each of the groups, x squared plus 4. And that's my final answer. Okay? I say or memorize here because you can also group them in the final things by putting the numbers out front in one binomial, and then the other binomial is the parenthesis that they both have in common. They both have x plus 5, write that as one of your answers, one of your binomials, and the numbers out front, they come together to be your other binomial when you factor it. Okay, that's the way to just memorize it. So that's factor by grouping. Hopefully you wrote down this process in your notes, okay, because that's what we need. The last way to factor we need to know is difference of squares, which is an identity. I don't know if you've learned an identity before, but this is what the identity says. X squared minus b squared, difference, right? We can only do this process when we are subtracting. Notice both of these examples are minus, right? They're both subtracting. We can also only do this when we have perfect squares, right? Notice 49 and 36 are both perfect squares, okay? And also x squared is a perfect square. And what we need to do, once we realize I'm subtracting and I have perfect squares, we need to take the square root of both of those terms to get my factor setup, okay? So I think about my first term here. Let's get color code. X squared. So I take, okay, what's the square root of x squared? It's x. That gets written in the first spot in both of my binomials. The identity says that one's plus and one's minus, so I can go ahead and write that. And then I need to go ahead and take the square root of my other term, of my b, really. Why isn't that red? So then I come on the side, okay, the square root of 49 is 7. That gets written in the second spot of both of those binomials, and there's my answer. Okay? Same thing I can think about for the second one here. I realize I'm subtracting. X squared and 36 are perfect squares, so I'm going to get my answer. I'm going to take the square root of my first term, which is x squared. That's x, so I'm going to stick that in the beginning of both of my binomials. Oh, one's adding and one's subtracting. And now I need to take the square root of my second term. Square root of 36 gives me 6. And that's the second piece to my binomials. And there's my answer. Okay? Guys, so here's a quick review of the 4 main types of factoring that we need to be able to do this year. Okay? We'll start with those. Use this video when you go through the practice. You guys rock. Awesome job.